NASA's space probe has sent a shocking warning to Earth. Voyager 1 has earned the trust of science enthusiasts across the world for its unprecedented journey through the depths of space. Originally designed for a 5-year lifespan, this resilient spacecraft has defied all expectations, enduring for nearly 5 decades. Now, we are on the verge of a groundbreaking discovery as Voyager 1 has detected unknown objects passing by in space. What are these unidentified flying objects? Join us as we uncover how Voyager 1 detected 300 unknown objects passing by in space. We marvel at the breathtaking splendor of Earth's natural wonders, the cascading waterfalls, towering mountains, and vibrant ecosystems. It is difficult to realize that our planet is only a glimpse of the grandeur that awaits us in the vastness of space. For centuries, scientists have pondered the mysteries that lie beyond our solar system and the watchful gaze of the sun. Fortunately, Voyager 1 emerged as mankind's most ambitious attempt to seek answers to these timeless questions. This remarkable spacecraft has ventured beyond the limits of our most powerful telescopes, collecting first-hand data about the vast expanse of interstellar space and relaying it back to Earth. After decades of an extraordinarily successful voyage, Voyager 1 has delivered a startling message that has left scientists astounded. Voyager 1, NASA's most trusted interstellar spacecraft, just announced that it has detected 300 unknown objects passing by in space. But before we find out the mystery behind these unidentified objects, let's first explore one of the most remarkable stories of man's exploration of space. In August 2012, an extraordinary milestone was achieved by the Voyager spacecraft. After a remarkable journey, Voyager 1 officially reached the outermost boundary of our solar system, crossing what is known as the heliopause. However, this feat was by no means an easy task. As Voyager 1 ventured farther away from the Sun, the availability of sunlight to power its instruments and systems diminished significantly. The primary source of power for the spacecraft comes from 3 radioisotope thermoelectric generators, RTGs. These ingenious devices convert the heat generated by the natural decay of plutonium-238 into electricity. Over time, the declining heat output of the RTGs has resulted in a reduction in available power. This decrease in power has a direct impact on the operation of various systems on board, including scientific instruments, data transmission, and communication capabilities. To conserve energy, certain non-essential systems and instruments have been deactivated or placed in a dormant state. However, as the power continues to decline, critical systems may require further optimization or even shutdown to prolong Voyager 1's operational lifespan. The stark reality is that if no action is taken, Voyager 1's ability to function will be severely limited. And even if it manages to continue operating, its usefulness to us may be greatly diminished. Adding to the challenges is the vast distance between Voyager 1 and Earth. As the spacecraft ventured into interstellar space, the strength of the signal transmitted from Voyager 1 weakened considerably. Currently, it takes over 21 hours for signals to travel from Voyager 1 to Earth. The weak signal, combined with interference from background noise, presents a significant obstacle to successful data transmission and reception. Moreover, the transition from the heliosphere to interstellar space exposes Voyager 1 to vastly different temperature conditions. Within the heliosphere, the spacecraft was closer to the Sun and experienced higher temperatures. However, as it delved into interstellar space, it encountered extremely low temperatures. These temperature extremes can impact the spacecraft's materials, electronic components, and systems. Thermal stress and the expansion and contraction cycles resulting from these temperature variations could potentially affect the structural integrity of certain parts. Extreme cold can cause materials to become brittle, leading to possible fractures or degradation of seals and connectors. Furthermore, the temperature variations also influence the performance of the RTGs, which are designed to operate within specific thermal ranges. The cooling of the RTGs further exacerbates the power challenges previously mentioned. Compounding these issues is the presence of a sparse distribution of dust particles within interstellar space. Although these particles are minuscule in size, they pose a risk to the Voyager 1 spacecraft. When the spacecraft encounters interstellar dust, these particles can collide with its exterior surfaces, causing wear and tear on protective coatings, antenna surfaces, or other sensitive areas. The accumulation of dust on the instrument's optics or sensors can interfere with their functionality, degrading the quality of the data collected. Additionally, the Deep Space Network, NASA's global system of antennas for communicating with deep space missions, has to allocate limited resources to receive Voyager 1 signals. This allocation of resources makes communication opportunities with Voyager 1 much more infrequent than ever before. Let's stop right here and bring you up to speed with the incredible achievement of the Voyager probe. Before the recent discovery of 300 unidentified objects, what are the achievements of Voyager probes? The achievements of the Voyager twin probes stand as a testament to human ingenuity and the boundless spirit of exploration. These remarkable spacecraft, more than 4 decades ago, embarked on a journey that forever changed our understanding of the distant worlds in our solar system. Their early observations of Jupiter and Saturn's moons shattered preconceived notions and left researchers in awe. These moons, once thought to be inactive and scarred like our own moon, proved to be vibrant and dynamic, teeming with geological activity. Among the Voyager probes, Voyager 2 stands out for its extraordinary milestones. In 1986, it made history by becoming the first spacecraft to venture close to Uranus, providing humanity with the first up-close look at this enigmatic planet and its moons. Just 3 years later, Voyager 2 accomplished yet another groundbreaking feat with a flyby of Neptune, revealing the wonders of this icy giant. To this day, Voyager 2 remains the sole spacecraft to have ventured into the realms of Uranus and Neptune, a testament to its pioneering spirit. As the Voyager spacecraft continued their epic odyssey, NASA implemented various measures to prolong their operational lifespan. Over the past 3 decades, non-essential components and heaters have been deactivated, conserving energy and ensuring that these intrepid explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030, a testament to the resilience and durability of the Voyager probes. For the dedicated scientists and engineers who have been involved in this extraordinary endeavor from the very beginning, the culmination of the Voyager missions is both a moment of pride and a touch of melancholy. Their unwavering dedication and tireless efforts have far exceeded their initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, fueled numerous scientific discoveries, and sparked the imagination of countless researchers and space enthusiasts. What truly sets the Voyager probes apart is their meticulous design as stable platforms with a rotation rate over 15 times slower than the hour hand of a clock. These spacecraft were engineered to minimize visual blurring as they captured images and data while hurtling through the vastness of space. Even before their encounters with the outer planets, their impressive imaging capabilities began to amaze scientists and the public alike. Months before reaching Jupiter, the Voyager spacecraft began transmitting images of this gas giant, captivating audiences at NASA's Jet Propulsion Laboratory. These early images showcased the mesmerizing swirling clouds and the iconic Great Red Spot, leaving observers in awe. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. This moon, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected peculiar signals from Io, which were confirmed by the vivid images they captured. Towering volcanic plumes and a surface scarred by volcanic material ejections were unveiled. One of Io's most prominent volcanoes has erupted with a force 30 times greater than the height of Mount Everest, covering an area nearly the size of France. While the cameras of the Voyager spacecraft were eventually powered down to conserve power and memory before their journey into interstellar space, it is worth noting that the photos they captured did not include Mercury and Mars for various reasons. In addition to the Voyager 1 and Voyager 2 interstellar probes, NASA has also operated other notable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed by Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Voyager 1 continued its solitary voyage for another 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to catch up with, NASA did not publicly announce this remarkable achievement until 2013, adding to the intrigue and wonder surrounding the Voyager missions. One technique that truly shone in the legendary Voyager missions was the gravity assist maneuvers. These maneuvers played a crucial role in propelling Voyager 1 and Voyager 2 on their audacious quest to explore the outer reaches of our solar system. In order to reach these distant destinations and gather invaluable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assists provided just that. Picture the two intrepid spacecraft, Voyager 1 and Voyager 2, embarking on their grand tour of the solar system. Instead of relying solely on their engines, they engaged in a celestial dance with some of our solar system's heavyweight planets. This intricate choreography allowed them to utilize the immense gravitational pull of these giants to slingshot themselves on their way. By doing so, they conserved precious fuel and gained the velocity required to visit multiple destinations, leaving a lasting legacy of exploration and discovery. The recent discovery was the detection of 300 unknown objects, a malfunction or something far more mysterious. As this remarkable probe glides through space, dutifully gathering and transmitting valuable data back to Earth, the responsibility of examining this data falls on diligent scientists eager to unravel the mysteries of the cosmos. Recently, amidst the steady stream of information, a captivating discovery emerged, a signal that perplexed and intrigued researchers around the world. Voyager 1 had detected the presence of 300 unknown objects traversing interstellar space. These unidentified objects, emerging from the depths of interstellar space, posed a profound challenge to our current understanding of the universe. When Voyager 1 transmits information, it is typically a straightforward process. However, on this occasion, the data arrived scrambled and unintelligible. Numerous questions arose, but answers remained elusive. Curiously, despite the peculiar nature of the transmitted data, Voyager 1 itself remained unscathed and continued to operate in remarkable condition. Its communication link with Earth remained intact, and the signal retained its strength, allowing valuable information to be sent to NASA without significant issues. Strangely, none of the spacecraft's fault protection systems were triggered, indicating that it had not entered a protective safe mode as it would in the presence of threats. It became evident that Voyager 1 was not under attack, leaving scientists to wonder what could be causing the scrambled or inaccurate telemetry data. Was it interference from external cosmic phenomena such as radiation or high-energy particles? Or could it be attributed to an entirely unknown phenomenon lurking in the depths of interstellar space? If the latter were true, it would challenge our understanding of space and communication in the interstellar realm. To ascertain the truth, a meticulous analysis of various potential factors became imperative. The research team at NASA embarked on a thorough examination of Voyager 1's systems. They carefully considered the impact of cosmic radiation on electronic components and explored the possibility of temperature fluctuations affecting the stability of its sensitive instruments. It was postulated that something unusual might have occurred just before Voyager 1 reached the heliosphere, and the natural challenges encountered during the transition could have led to the scrambling of data. However, it became apparent that Voyager 1 was not in an area where these challenges were concentrated enough to pose a significant threat. Consequently, the team also scrutinized the intricacies of Voyager 1's communication systems, investigating potential signal distortions caused by cosmic noise interference or subtle shifts in its trajectory. The search for answers necessitated a meticulous analysis of all potential factors. The research process was not instantaneous. It spanned several weeks. The team employed advanced data processing techniques, developed innovative algorithms, and simulated various scenarios to isolate the root cause of the unusual telemetry anomalies. This rigorous work finally bore fruit. After months of receiving scrambled data from the spacecraft, scientists and engineers successfully restored the clarity and reliability of the information streaming in from the far reaches of interstellar space. The source of the problem was traced back to Voyager 1's Attitude Articulation and Control System, ACS, more specifically to an unexpected source, a dormant onboard computer. Remarkably, this non-functional computer had somehow started operating, leading to the corruption of the transmitted data. Nevertheless, the rest of the spacecraft systems remained operational, and data collection activities continued unhindered. With the source of the problem identified, engineers swiftly devised a solution. They sent a command to Voyager 1, instructing the ACS system to switch computers for transmitting telemetry data, a process complicated by the 22-hour radio signal delay between Earth and the spacecraft. Troubleshooting involved consulting 1970s manuals to reset the system responsible for data transmission, which successfully resolved the issue without compromising other components. This restoration highlighted the importance of combining past knowledge with present technology in overcoming challenges in space exploration. Engineers suspect a faulty command triggered Voyager 1's deviation to a non-operational computer, but mission managers remain optimistic, emphasizing that the incident doesn't threaten Voyager 1's long-term well-being. Voyager 1's successful passage beyond the heliosphere, marking its entry into interstellar space and subsequent observations including changes in particle intensity and magnetic field direction, deepen our understanding of the heliosphere boundary and interstellar dynamics. The encounter also raised questions about unidentified objects detected by Voyager 1, leading to theories about rogue planets, ancient interstellar probes, and potential extraterrestrial involvement, sparking ongoing scientific inquiry into the true nature of these objects and Voyager 1's experiences. In conclusion, Voyager 1 continues to defy expectations and push the boundaries of our knowledge about the cosmos. Its longevity and resilience serve as a testament to human ingenuity and the spirit of exploration. As it continues its journey through interstellar space, Voyager 1 remains a beacon of discovery, inspiring future generations to unravel the mysteries of the universe.